Hi again, I'm Yves Rosto from Jean Bou Biotech, and I'm here to give you some insight about the calculation of analytical sensitivity. What is analytical sensitivity? The IPPO standard tells us that it's the smallest amount of target that can be detected reliably. Targets tell us that it's only for infected samples. We also read that it's smallest amount, but what if absolute viral charge is not defined? And reliably, what is reliable? We could use an infected sample and dilute it until we don't detect the virus anymore. We then record the last level of dilution where we detect the virus. But we know that around detection limit, variability of the result increased. And then this result is sensitive to unique result and potential detection errors. Moreover, true limit can be between tested level of dilutions, and we don't get any information about the reliability of the detection. As a solution, we propose to replicate samples at each dilution level and treat the problem on a continuous scale by modeling detection probability via dilution or concentration level. Here, we have an example with 5 dilution levels and a fixed number of samples in each level. We record here, for example, detection rate of 100, 100, 82.1, 0, and 3.6%. If we put those results on a graphical representation, we can see that the detection rate dropped rapidly after a dilution level of 10 exponent minus 4. To model the detection probability, we could use a linear regression, but with damned problem. Probability is bounded between 0 and 1, while linear regression isn't. We could get probability higher than 1 and lower than 0. Instead, we will use what we call logistic regression. It replaces the classical formula of linear regression, probability equal beta 0 plus beta 1 multiplied by the dilution level, by another, where the probability is first transformed by a function which is called the Logit, which is the log of the probability divided by 1 minus the probability. We can see now that the new model is bounded between 0 and 1, and it fits well to the observed S-shaped decrease of the detection probability. With this model, as it is continuous, we can predict probability of detection for any dilution level in the observed range. So we are now able to define reliable by associating a fixed minimal probability of detection, for example, 95%. How can we calculate the associated dilution level? Well, once you get the equation of the logistic model with the value of beta 0 and beta 1 which fit your observed value, you can very easily calculate the limit of detection for any given probability by the formula which is on the screen, which is the logit of the probability minus beta 0 divided by beta 1. In our example, the formula is the logit of the probability is equal to 17.52 minus 4.04 multiplied by the dilution level. Then, the logit of our probability, 0.95, is equal to the log of 0.95 divided by 1 minus 0.95, and it's equal to 2.94. The limit of detection associated to a probability of 95% of detection is then equal to 2.94 minus 17.52 divided by minus 4.04, and it's equal to 3.6. As a dilution level has been represented on a log scale, the dilution level is then 10 minus 3.6. Once the logistic model has been fitted to your own observation, you can adjust the level of probability to your own needs. For example, 99% or 90% or 80% and get an answer for each of those probability levels to compare your methods. Thank you for your attention, and if you have any question, my email is here at the end of this video.